Hi, welcome. My name's Andy Swing. I'm a hardware engineer here at Google. I've been working here for the past year and a half or so. Here today to talk about automating Christmas lights, or holiday lights, if you so choose. A couple of years ago, I set out to do this on my house, and I'm going to tell you a little bit about what I've done there and the different options available to you that I've looked into. I think it's pretty fun. So what are we going to talk about? Well, maybe why would anyone do this, right? Seems like maybe a crazy idea. Show you kind of the basics of a real simple system. We'll talk about how to hang up the lights, things to watch out for. It's not quite as easy as you might think. You can just slap them up and have it go. I'll talk about some of the different hardware components, the software that controls that hardware, and then I'll kind of show you how it gets all put together using my house and someone else's as an example, and give you some links so that you can check it out for yourself at the end. So why on earth would you do this? Well, I can tell you that it's a lot of fun. I enjoy it a lot. I'm an engineer, so I spend all day doing technical, nerdy stuff, and this is sort of a creative outlet, right? Something about being able to write software and build hardware that does something sort of artistic just fascinates me for some reason. It's also a good learning experience, so I learned a lot about different aspects along the way. Plus, it just looks cool. I have a bunch of different patterns and stuff, and I always see the cars slowing down in front of my house. That's kind of fun. Believe it or not, animating your Christmas lights can actually reduce the amount of power they take. So sure, you might throw up a lot of strings, but you can actually sort of mitigate the power costs and things there. Plus, it's not just for Christmas. You can spice up any holiday with automated lights. I did some stuff for Halloween this year, for example. Anything. The door's wide open. So what does it take to do this? Well, you need a lot of lights. Preferably at least twice as many as your neighbor, because you have to. That gets into a bad cycle, by the way. You'll need some extension cords to plug things together. You need some sort of hardware to control the lights, right? So you could plug them all just into the wall, but then they'd be all on all the time. That's no fun. And with the hardware comes software. So you have to have some way to build patterns and control everything in a neat and easy-to-use way. And it takes a lot of patience. It takes a long time just to hang the lights. It takes a long time to write sequences and things. If you want to build one to like a song, that can take up to 20 hours for one song. 3 minutes of glory. So depends on how crazy you want to get. So here's kind of what a simple system would look like. You have a control computer that's running the show. There's the hardware control box and a bunch of lights that plug in somehow. Plus, you need a good source of power, depending on how many lights you put up. So that's kind of what it looks like. So let's talk about putting up the lights. You see those houses where people just kind of buy a whole bunch of stuff, and they throw it on. It kind of looks icky or overdone, right? So it takes a while to kind of plan it out. And you can use sort of the existing lines of your house. So outline windows, put it around doors, use the eaves, all kinds of things like that make it look sort of part of the house. That gives a better look, I think. It's also sort of challenging to work out, where do I put the lights? How am I going to plug them in without it looking ugly and nasty? Plus, you always end up with a string that goes all the way around the window, and then you have like half the window left. What do you do with that? So it takes some work there. Plus, most of the lights you can buy are either like multicolor or white. That's OK. It's a lot more fun if you get 6 strings, each of a solid color. Then you can control the different colors and play around. The other note about strings is you can buy really cheap strings. Don't do that. You'll end up spending more in the end. So it pays to spend a couple extra dollars and get quality hardware. But that's just me. You have a fixed number of channels that you can control. So if you go out and you buy 100 lights, well, you're going to have to pay for 100 channels of control for those lights. You could gang them together to some degree, but that doesn't look as good. If you get really nuts, you actually have to worry about power capacity. Like, will my house have enough power to run all these lights? Believe it or not, people run into these issues. I'm not there yet, but someday. Plus, all this stuff is outside. So think about it, it's kind of winter season right now. It's rainy and wet and all that. So you have to be a little careful where you put stuff and just to keep it safe and dry and working without issue. So here's how I did my setup. I like Google SketchUp. It's fun. So I went and drew a picture of my house, and it's actually to scale. So I measured some key dimensions and things, and SketchUp is really, really good at that. So that let me sort of plan out, OK, I have 10 strings that are 15 feet long. Where can I stick those? So I came up with sort of a map. OK, I'll put these here and those there. And that made it a lot easier when it came time to hang it, because I knew the lights I had and where to put them and all that. Plus, it makes kind of cool pictures. So here's just an example. So there's lights around a window and things, which is all planned out. OK. Some more lights. So you can see I actually have like a whole bunch of multicolors along the top and things like that. Cable management's sort of an issue as well, which we'll see more. Yeah, lots of extension cords. And yeah, cable management, right. So you don't want cords hanging all over the place. Preferably you tuck them under eaves and things like that. Yeah, I wish I could have done that better. So that's hanging the lights. Now you got to worry about controlling them. So there's actually a bunch of different theories out there, different types of things you can build. You can buy stuff that just works out of the box. You can build crazy kits. You can build it all from scratch if you want, using surplus components. There's different trade-offs. But the basic idea is that you have an AC light, like Christmas lights or anything, little trees, things like that, that you want to control with a low voltage signal from a computer, right? Usually you want to keep like high voltage AC and low voltage computer separate. So that's a little bit of a challenge. So there's sort of two main classifications. You can build or buy simple controllers that just let you turn the light on or off. So it's full intensity, zero intensity. The cooler ones let you dim the lights, and you can actually do things like fades or color mixing and things like that. That's a lot more fun, but it costs a little bit more money. So let's talk about how you would build one of these on-off controllers. Usually it uses a component called the solid-state relay. So that's just a simple little block, and it takes a low-voltage signal in, and it controls high voltage on the other side. And it's actually optically isolated inside, so keeps things separate, which is good. There's this cool website called planetchristmas.com, and they talk about sort of their strategy for this type of approach. The thing that's sort of unfortunate is that every controller you build has to have a wire that goes all the way back to the computer. So if you want 100 channels, that's 100 wires. You got to make their way back. So that can get a little out of hand, as we'll see in these pictures. So here's an example schematic they had. This is a box that could control 8 channels. So they have 8 little relays over here. Those signals go off to the computer, and they have their power that comes in. But it really doesn't look that pretty. Seems like maybe something could go wrong there. So as I was saying, you have to have a signal that comes back to your computer for each one of these. This guy has more pictures than this, but it gets kind of gnarly with all the cables and everything. He actually has these 2 big cards in the computer that drive digital outputs, which are kind of expensive and clunky. And this won't let you dim, by the way. This is only on-off. So it really doesn't scale well. So there's also a bunch of commercial controllers that you could just go out and buy. There's 2 companies that are kind of the main resellers of those. It's Lightorama and Animated Lighting. I'm not being paid by them. These are just the two people out there. I actually prefer Lightorama's gear. It makes a little bit more sense, and that's what I used. But basically, their products are the same. You can buy an 8-channel or 16-channel controller, which is pretty cool. So you can get a lot of lights on there. And the best part is that it uses a serial protocol to communicate between the controllers. So that means even if you had 100 controllers, all you have to do is run one Cat5 cable that daisy chains its way between the boxes. So that makes sort of spreading your controllers around your house easier. It's a lot easier to debug and things like that, too. So you can buy them pre-built. And some of them even are like even in an enclosure and everything. You can also buy them in kit form, which is what I did because they're cheaper, because I can solder. So that's another way to do it. I recommend against kit form if you've never done that before. It does take a bit of work. It took me a good 4 hours to solder it up, and I've been doing that for a long time. So here's kind of what these commercial controllers look like. This is one of the ones that's straight out of the box. It has cables on it, the whole deal, plug in and go. This is one I built from a kit. So the only thing that came in the kit was the circuit board. I had to solder it all together. And I put it in my own enclosure. I put extension cords on there, the whole deal. Turns out that costs more than buying the kit, or the completed one, rather. Depends. Depends on how much your time is worth. So these are some cool diagrams from Lightorama. And this kind of shows you how you could set up a show. So this is really simple. They have 7 lights, control computer over there, and there's that little serial cable I was talking about. Comes with a controller box, you plug it in, away you go. You can even do audio with their software. You can get crazy, too. So here they have a whole bunch of controllers that are wired in there. You can actually buy these little wireless things to send them across. So I don't know if you had a huge mansion, you wouldn't have to string cable everywhere. I wish I had that problem. And you'll notice they also have a FM transmitter. So one of the really popular things to do is to put these to music, and then you can broadcast that music. So people that sit outside in their car can listen to the music while the show goes on. Pretty cool. I'm not there yet either. OK, so we talked about dimming AC power. And I thought I'd go into a little bit of technical detail and tell you exactly how that's done. So if you look at the AC power that comes out of your wall, it's a sine wave, 60 hertz here in the US. So how could you sort of vary the amount of power that's delivered to the lights? That's what you want to do. Less power means less brightness. So you can use this thing called phase angle control. You use this little triac chip. Basically, the idea is that you want to cut off pieces of the sine wave. So the area that's over here, it sort of equates directly to the brightness. So you can kind of turn it on over here and shave off half, and the other half gets delivered to the light. And that can be pretty fine-grained. You can get over 100 steps. It's pretty cool. So that's kind of how it works. If you want to know more, just Google it. So now seems like an appropriate time to mention some safety items. Electricity is dangerous, believe it or not. We all play with it every day, but it can bite you. So especially with Christmas lights, right? I was talking about them being outdoors, and there's weather issues and water everywhere, and well, that sounds a little sketchy. So grounding is really important. The whole theory behind grounding is that, say I had one of those controller boxes, right, and it was shorted out inside. If I touch that box, I become the path to ground right through my heart, and that's bad. So grounding is all about giving this sort of safety path so that it doesn't go through your body. So you never want to use Christmas light controllers and things on ungrounded circuits. Keeping things dry. That's also very important. One of the techniques I like to use, I have some little trees that are out in the yard, and they're less protected. So I run an extension cord up to the base, and I run the light plug underneath, and I put the whole thing in a little plastic baggie, and I zip tie it. That way, water can't get in, and everybody's happy. The other thing to talk about, too, is GFCI protection. So you may have seen these outlets in your home. They're usually in like the bathroom and the kitchen, outdoor outlets, things like that. It's actually a safety protection device. And what happens is it detects when there's current flowing not through the normal path, like through your body, for example, and it'll shut off the circuit. So this is a good thing, right? Then if our Christmas lights are shorting out, it'll just turn off. The bad thing is that that'll shut down your show. And also, if you just have Christmas light strings across the ground, there's enough sort of leakage there to trip GFCIs. So if you look on the forums and things, you'll see that people don't like these devices, and they usually try to get around them, but they're there for your safety. If you're careful about not leaving plugs and stuff on the ground where they get wet, it's not too big of an issue. All right, that's enough about that. Let's talk about software. So there's a few different software options. It's actually kind of lacking, in my opinion. There's no open source stuff in this area. There's some freeware and 2 commercial packages. Basically, both Lightorama and Animated Lighting each have their own software that they're happy to sell you along with the hardware. It's like $100 or something. So the basic idea of all this software is to create sequences, right? And a sequence is nothing but a bunch of slices in time where you define the values of all your lights. So for example, you might change the value 10 times a second. So you kind of build this spreadsheet looking sort of thing that defines your pattern and things. And I'll show you a picture in a second here. So you create all these different sequences. They might correspond to a song. They might not. They might just look cool. Then you want to sort of build a list of sequences to walk down through. And using the software, you can actually turn that on at like 5:30 and have it run through and do its thing on a schedule and things like that. So it's pretty advanced. Yeah, let's see. So there's one freeware option that I used called Vixen at vixenlights.com. I think there's a link later. It's a pretty good editor. It has some pretty cool plugins. There's one where you can import a picture of your house, which I threw my Sketchup diagram into. And you can actually draw the little lights on there. And as you're building the pattern, you can preview what your sequence looks like, which is really useful because trying something out and then running outside to look at it gets old after a while, especially when it's cold outside. The other bonus of Vixen is that it stores its sequence data in an XML file. So I actually wrote some of my own software to parse the XML out and run the show. So if you like hacking with stuff, it's a good option for that. It also supports a lot of that sort of do-it-yourself hardware. And their website has a lot of good links to different things you can build. So if you're looking to do this all yourself, this is a really good piece of software for that. Some good community behind it. It kind of has some support for doing stuff to music, but it's not that advanced yet. The major downside is it doesn't support any of those commercial controllers. So you can't buy a Lightorama controller and use it with Vixen. You have to use their software. So here's kind of what it looks like. So across here is all those time ticks. If you look at the top, there's actually a 10-second pattern split into 100 different pieces. And you have all your lights down there, and you can assign them colors and things. So you can see there's kind of a neat little pattern going on up there, as well as a fade at the end. So as you're changing the intensity down, the color intensity changes. So you kind of get a good visual representation of what's going on. And it's pretty easy to use. It's all point and click and everything. The commercial software, I haven't actually used it myself, but I've seen it. It's basically the same. It'll work right out of the box with their hardware, whereas Vixen might need a little messing around with. They actually have a lot better support for doing your show to music. You can actually buy little pieces of dedicated hardware that'll run MP3s and things as part of your show, which is pretty cool. They also have some good hardware testing utilities. So especially if you're going to build them from a kit, you want to know that it works, and you can test it all out, which is cool. So I'll tell you about my setup. I have 32 strings of lights all over my house. I have, so far, 12 different sequences. Like I said, it takes some time to build them. So the controllers I use are Lightorama. I have 2 of them. Each have 16 channels. If everything's on, I'm using 1,200 watts, which is not so bad. That's safe enough to run from a single outlet. But like I was telling you, if you write your patterns right and everything, you can severely reduce the power consumption. So it averages about 300 watts, which is not so bad. I can justify that one. And I use Vixen to build all my sequences. I wrote some custom software to parse through those and control the hardware. Did it all in Java because it was easy, and it actually works. And that runs on a Linux box every night. Some of the things that I'd like to do in the future is have it go out and figure out what time the sunset is and turn the lights on exactly at sunset every day and things like that. Those sort of things are you can only do if you write the software yourself. So where did I put my controllers? Under the eaves on each side. So this let me sort of run the cables from the corners out to the lights for each half, which was good. The year before, I put all my controllers in one corner, and I had this big bundle of cables, and it was all ugly. So it takes some planning, like I was saying. There's one of the controllers. That's the one I built from a kit. And yeah, it's under the eave, so it stays dry. And there's the other one from this year with lots of ugly cables and things. But it's also protected. Some more shots, cables and things. I hope that gutter doesn't overflow. That could be a problem. More lights. So here's a video of one of the sequences that I have. It's kind of cool. It's a little like Knight Rider effect. Goes back and forth. So I want to show you the pattern that corresponds to that video. So it's actually pretty simple, right? It's a nice little sawtooth wave thing. And you can see one of the interesting things I did here is it's not just one box on. It's kind of on and then fades off a little. So it gives the motion sort of a trail. And I discovered that it gives it a much more real sort of look, which is pretty cool. So yeah, that pattern didn't take long to write. So here's another video. So this one's got a little bit more motion, different colors, stuff like that. And the pattern for that one's a little bit more complex. And you can kind of see the elements from the video, right? Kind of starts in the middle and works its way out. The other thing I should say about the patterns is, this lasts for 5 seconds, right? Obviously, it was running for more than 5 seconds. So it's sort of a wraparound deal. So you have to time your pattern just right so that this point has to wrap around to this point in order for it to work well. And you can see that this pattern kind of does. You get into some frustrating timing issues there. OK. So my house is pretty cool, I think. I spent enough time on it to be. There's this other house here in Sunnyvale, actually, locally, that completely trumps mine. These guys are 2 houses next to each other. I think they're retired engineers or something like that. They have 60,000 some odd bulbs. That's a lot. Spans 2 houses, like I said. If everything's on in their house, it's 25,000 watts. I don't want to see their electric bill. 188 channels. They have some really good animated songs and things, 30 of them, actually, which is pretty cool. Some other displays. These guys do it right. It's very cool. So I have some pictures of these to show you. They do a lot of, basically any object in their yard is covered with Christmas lights. And then they add some, like trees and reindeer and things like that. It's quite a sight. I'm sure their neighbors hate them. Some other cool things. These are some of their LED lights, I think, which are pretty cool. Yeah, so a note about LED lights. I was going to mention that earlier. Get more popular, which is cool. They burn a lot less power. They don't quite dim as well as a incandescent bulb with the traditional controllers. So if you're going to do LEDs, you should go all out and spend a lot more money on the right kind of controller to get the right effect. But you can limp along for now. So you probably saw, it was like a couple years ago, this guy did this crazy video, and everyone in the world's seen it, where he did this kind of thing to his house to music. Well, this house in Sunnyvale I was talking about did sort of a rebuttal to this, and we'll play that for a minute here. Pretty crazy. These guys spend way too much time on this stuff. But there's a link to the website. I encourage you to go check it out. And if you're local here, you should definitely go see it because it's a million times better in person. Plus, they got a whole bunch of other stuff going on. It's very cool. But they've been doing it for a long time. So maybe now you want to know more. You want to go do this for yourself. There's a lot of different resources available. Easiest way to get started is just to Google, holiday light display or whatever. But there's some links to the 2 companies there. The Vixen software that I was talking about. Planet Christmas is this cool website that has a whole bunch of different how-to information and links to other sites and things like that. It's another good resource. And then here's the link to the Severance P's house that's here, local. It's pretty cool. Yeah. So I threw up a real quick Google Pages thing that has some of the links, and it'll have the presentation and things on there too. So if you want to know where any of them are, you can go there. And I think that's it. Yeah. So this is a video. It's like 4.5 minutes long of all the different sequences that my house does. So I'd like to open the floor for questions now. Yeah. Yeah, just go ahead and step up to the mic.
It's kind of silly, I guess, for the benefit.
For the video.
So besides the making the changes for different times when the sun sets,
Sure.
what other changes would you were you anticipating of making?
Well, I got a lot of ideas, I guess. Try to remember what they all are. I'd really like to try to do more things to music, because I think that's really fun, but it's a time sink. Maybe I'll get started in July or something. More lights is better. I don't know. It's kind of open to possibilities. It would be kind of cool to set up a web page where people could pick different patterns, or give them sort of the base Vixen file so they could write patterns of their own. Maybe have a contest or something so people could design things for my house and I wouldn't have to do the work. Lots of ideas. Yeah. Cool. Other questions?
Hi, it's Andy, right? Thank you for the talk. I enjoyed it. I wanted to say I liked your second house better than the first one. But I wanted to ask about music synchronization, and I wondered what tools are available currently or should be made available besides these based on, hand creating a specific and carefully timed pattern to sort of deal with music. Maybe you just play it some music and it makes something up.
Sure.
Based on what it hears.
I think that'd be really cool. If anyone wants to write that software, that would be awesome. Yeah, I think there's plenty of opportunity to employ different algorithms and things that could maybe know about the different colors that you have set up and things like that. There's some really simple things that people do based on different tone levels and things that'll turn on different lights. But in my opinion, it never looks as good as what you can do by hand. But yeah, there's plenty of opportunity there, I think.
So far, generally, everything is just by hand coded and drawn.
Could you imagine programming those sequences with 180 lights? I mean, it must take them forever.
No, I could not.
Yes.
Thank you.
Thanks.
Kind of a related problem is, let's say you have electronic devices that consume a lot of power when they're supposed to be off.
Sure.
So let's say a TV, and you want to have a single device that's controlled by a computer. Or do you know of what would be like an inexpensive way of doing that with just a single device, computer controlled?
Sure. So, there's lots of good options if you want to go really simple. 8 channels or less actually is sort of a key number. I believe there's some of those do-it-yourself projects that use the parallel port coming out of the back of the computer, and that gives you at least 8 channels, a couple more if you want to squeeze them out. So you can use those solid-state relays like that, and you can actually just drive them straight from the computer, no extra components. If you look online, there's a lot of different projects like that, and actually some pretty cool software. There's some different open source little things that let you control stuff over the parallel port and things like that. So yeah, the internet's a fun place. There's lots of cool stuff. Any other questions? Nope. Great. Well, thank you all for coming.